Ever get that feeling? Like you're reading about the latest cybersecurity breach and it's all just gibberish, or maybe you've heard the term pen testing thrown around and you're thinking, okay, what does that even mean?
Well, you're definitely not alone.
Yeah, the world of cybersecurity can feel pretty overwhelming.
It really can.
That's why we're here. Welcome to the Deep Dive. We're all about taking these super complex tech topics and breaking them down so you can actually understand them.
And for this deep dive, we're doing something a little different.
Yeah, this one's all about you, the learner.
Right. You sent over a really in-depth guide to ethical hacking and penetration testing, and, well, it's a lot to take in.
To say the least.
So think of us as your guides through this massive amount of information. We're going to pull out those key insights, the stuff you really need to know, without getting bogged down in the technical weeds.
Exactly. And this guide really does cover it all. It's got everything from setting up your own little hacking playground to some pretty advanced attack simulations.
Oh yeah, it gets pretty intense.
Our goal today is to give you a solid understanding of what penetration testing really is, the methodologies involved, the tools used, and even the kind of thinking that goes into it.
The mindset of a pen tester.
Right. By the end, you'll have a much clearer picture of this crucial, but often misunderstood, aspect of cybersecurity.
Sounds good.
Okay, so let's dive right in. What exactly is penetration testing?
You know, in the simplest terms, penetration testing is kind of like hiring a team of security experts
Okay.
to try and break into your systems, your digital systems.
Uh-huh.
But, and this is key, they're doing it with your permission.
Right, so they're not criminals.
Exactly. These are ethical hackers. They're simulating real-world cyber attacks to uncover any security weaknesses that malicious actors could exploit.
So they're finding the holes before the bad guys do.
Precisely. And the key difference between what they do and what actual hackers do is authorization. Penetration testing is completely legal, it's an agreed-upon process, and there are very clear boundaries right from the start.
So you're saying boundaries are really important.
Oh, absolutely.
They're like the rules of engagement.
Exactly.
Sounds kind of like setting the stage for a play.
Yeah, I like that analogy.
Before we get into those details, though, can you walk us through how a typical penetration test actually unfolds? Like, what are the main stages?
Yeah, absolutely. A penetration test usually follows a pretty structured approach. There are several key phases, and the very first one is information gathering,
Information gathering, okay.
often called reconnaissance.
Reconnaissance, right.
And this is where the testers basically act like detectives. They're trying to gather as much information as they can about the target organization. And this can be done in two main ways, passively and actively.
Passive reconnaissance. That sounds kind of like, I don't know, the digital equivalent of reading someone's trash.
Ooh, that's a pretty vivid analogy. I like that.
Tell us more.
So passive reconnaissance is all about collecting publicly available information without directly interacting with the target's systems. So think of it as piecing together a puzzle, but you're only using the pieces that are already out in the open.
Okay, I get it.
And this often involves using what's called open source intelligence, or OSINT.
OSINT.
Yeah, so for example, using advanced search techniques on, well,
Google.
Google. Some people call them Google dorks, but these are specific search queries that are designed to find very specific types of information.
Interesting.
So you can find things like publicly exposed documents, login pages, sometimes even employee information, just depending on what the organization has inadvertently left out there.
Wow. So it's all about what's already publicly available.
Exactly.
Interesting.
Testers also might look at social media, online forums, places like Stack Overflow.
Where people ask questions.
Yeah, and sometimes employees, when they're asking for help, they might reveal technical details about their systems without even realizing they're doing it. And that's valuable information for a pen tester. And even something as simple as WHOIS data. Yeah, this is a public database that tells you who owns a particular website domain. And all of this is about building a profile of the target's digital footprint, but without them ever knowing that they're being observed.
It's like a digital detective.
Exactly. And there are tools that can even automate a lot of this OSINT work.
Really?
Yeah. So tools like Spiderfoot,
Spiderfoot.
yeah, they can cast a really wide net across the internet, gathering all sorts of information. And what's really fascinating here is how sometimes seemingly small, unrelated pieces of public information can be combined to reveal some pretty significant potential vulnerabilities.
Wow, that's pretty interesting. So that's the kind of the fly on the wall approach.
Right.
But you mentioned active reconnaissance. That sounds a bit more, direct.
Yeah, exactly. Active reconnaissance involves interacting with the target systems directly.
Okay.
So this could be something as basic as sending out network pings just to see which systems are alive and responding.
Like knocking on the door digitally?
Exactly. Or probing for open ports.
Open ports.
Yeah, think of these like open doors on a building.
Uh-huh.
And these doors might lead to different services running on those systems.
Okay.
So, for example, there are tools like Eyewitness.
Eyewitness.
Yeah, this tool can actually take snapshots of websites and gather initial details about, the structure of the website, the technology it's using.
Got it.
And once we have this initial intelligence, the next phase is scanning and enumeration.
Scanning and enumeration. So isn't that just looking for those open doors that you mentioned?
Well, it definitely involves finding open ports, but scanning and enumeration goes a lot deeper than that.
Okay.
It's about knocking on those open doors and seeing what's behind them. Like, what kind of service is running? Is it a web server? Is it an email server? Is it a database?
So you're identifying what's behind the door.
Exactly.
Okay.
It also involves trying to figure out the operating system that the target machine is running, discovering user accounts, any shared network folders, even looking at the system configurations.
It sounds very detailed.
It is. And there's a very common, very powerful tool that's used in this phase called Nmap.
Nmap. I've heard of that one.
Yeah.
Hmm.
So instead of just passively seeing if a port is open, Nmap can actually send different kinds of probes to get a much more detailed response.
Okay.
So it's not just about seeing if a door is open. It's like identifying the type of lock on the door, who might be inside, that kind of thing.
That's a good analogy.
So it helps to really fingerprint those services and operating systems.
Interesting. So we've done our digital reconnaissance.
Right.
We know what systems are out there, what services they're offering. What's the next step? Time to look for weaknesses.
You got it. The next phase is vulnerability analysis.
Vulnerability analysis.
Yeah, and this is where all that information gathered during reconnaissance and scanning is carefully analyzed to identify potential security weaknesses.
Okay.
So the testers will assess the severity of each vulnerability, like how easily could this be exploited and what kind of damage could an attacker do. And they start thinking about potential countermeasures or fixes. There are tools that can help with this too, like Nessus and GVM. These tools have massive databases of known vulnerabilities, and they can automatically scan systems to see if they match any of those known flaws.
Sounds pretty convenient.
It is. However, it's really important to understand that just because a vulnerability exists, it doesn't mean it's actually exploitable.
Okay, so there's more to it than just finding a vulnerability.
Exactly. Manual analysis and understanding the context are crucial.
So human expertise is still really important.
Oh, absolutely.
Got it. And once you've spotted a potential weakness, that's where the hacking part, the part that we all kind of picture, comes in, right?
Yeah, you're talking about exploitation.
Exploitation, right?
Yeah. So this is the phase where the testers actually attempt to use those identified vulnerabilities to gain unauthorized access to the target systems.
Okay.
Or to the target data. And they often use what are called exploits. So these are pieces of code or sometimes specific techniques that are designed to take advantage of a particular weakness.
So like finding that unlocked window and then figuring out how to climb through it.
Perfect analogy. There are different types of exploits. Some can be triggered remotely, others require some level of local access, and some might let you run commands with the same privileges as the vulnerable application, while others might give you complete control over the entire system.
Oh, wow. That's pretty scary.
It can be, so the impact can vary widely depending on the vulnerability and the exploit being used.
So you've managed to get in.
Right.
What happens then? Do you just, send an email saying, hey, we were here?
No, definitely not. The post-exploitation phase is actually incredibly important.
Post-exploitation.
Once they gain access, testers try to simulate what a real attacker might do. So this could involve trying to maintain their access, so establishing what's called persistence, so they can come back later. Or they might try to move laterally to other systems within the network.
Oh, so they're spreading out.
Exactly.
Yeah.
They're using that compromised system as a stepping stone to reach other valuable targets.
Interesting.
And really importantly, they might even try to exfiltrate data. So basically, copy sensitive information without anyone knowing to demonstrate the potential impact of a successful breach.
Oh, that's clever.
Yeah, and there are tools for that too, like Packet Whisper.
Packet Whisper.
Which can simulate this data exfiltration, but in a controlled manner, of course. It's all about showing those real-world consequences of the vulnerabilities that were found.
Okay, so you've had your, ethical fun, what's next?
Well, I'm assuming the organization wants to know what you found and how bad it is.
Absolutely. The reporting phase is probably one of the most important phases of the entire penetration test.
Reporting phase, okay.
The pen testers compile detailed reports for the stakeholders.
Right?
And these reports are usually divided into a technical report and an executive summary. Two different reports.
Yeah. So the technical report gets into all the nitty-gritty details of each vulnerability, how it was exploited, the specific steps taken, all the technical stuff. But the executive summary, that provides a high-level overview of the findings.
Okay.
What's the business impact of these vulnerabilities and clear recommendations for fixing them? And these recommendations need to be understandable even for people who aren't technical experts.
Right, because not everyone on the receiving end of this is going to be a cybersecurity expert.
Exactly. So think of it as translating those complex technical findings into actionable business language.
I see, I see. And after the report is delivered, does the pen test just end?
Well, the final phase is remediation.
Remediation.
And this is where the organization actually takes those findings from the report and implements the necessary fixes, the security controls, to address those vulnerabilities.
So they're actually fixing the problems.
Right. So this could involve patching software, changing configurations, implementing new security policies, that kind of thing. And often, organizations will conduct a follow-up penetration test, sometimes called a retest.
To make sure it worked.
Exactly, just to verify that the remediations were effective and those vulnerabilities have been closed.
Makes sense. So we've covered the entire life cycle of a pen test.
We have.
But I know there are different kinds of penetration testing too, right?
Oh, yeah, absolutely.
It's not just one standard procedure.
Right. The scope and the focus of a penetration test, it can be really tailored to an organization's specific needs and concerns.
So it's customizable.
Yeah. So, for example, you have network penetration testing,
Okay.
which focuses on the security of an organization's network infrastructure,
Yeah.
both internal and external.
The network.
Then you have web application penetration testing.
Web applications, right.
So this targets vulnerabilities within web-based applications, like online banking portals, e-commerce sites, things like that.
Makes sense.
And if an organization relies heavily on wireless connectivity, well then,
Wireless penetration testing.
Exactly. So this assesses the security of their Wi-Fi networks.
All right.
And then there's social engineering penetration testing.
Social engineering.
This one's interesting because it focuses on the human element of security.
The human element.
Yeah, so this might involve things like sending simulated phishing emails.
Trying to trick employees.
Exactly, to try and trick employees into revealing sensitive information. Or it could even involve physical attempts to gain unauthorized access to buildings.
Like what?
Like, imagine someone dropping infected USB drives in the office parking lot just to see if employees pick them up and plug them into their computers.
Oh, wow. That's sneaky.
It is, but it happens.
So social engineering is all about exploiting human behavior.
You got it.
And I've also heard these terms, white box, black box, and gray box testing.
Yeah.
What's the difference there?
These terms describe the amount of information that the penetration testers are given beforehand.
Okay.
So in white box testing, the testers have full knowledge of the target system. They get things like network diagrams, source code, sometimes even login credentials.
So they know everything.
They know pretty much everything.
Okay.
And this allows for a very thorough and efficient assessment because they can focus their efforts on the most critical areas.
Makes sense.
Black box testing, on the other hand, that's the opposite. The testers are given very little information, if any, about the target.
So they're going in blind.
Pretty much. And this simulates the perspective of an external attacker who doesn't have any insider knowledge.
Right.
And this can be really useful for discovering vulnerabilities that might be overlooked when you have all that inside information.
Makes sense.
And then gray box testing is kind of a hybrid approach.
Okay.
The testers get some limited information, so it's kind of a balance between the efficiency of white box and the real-world perspective of black box.
So it really depends on what the organization wants to get out of the test.
Exactly.
Do they want to see how an insider might exploit things or how someone with no prior knowledge could break in? Now, shifting gears a bit, what kind of mindset do you need to be a successful penetration tester? It sounds like it takes more than just technical skills.
It absolutely does. A good penetration tester, they need a really strong foundation in critical thinking and problem solving.
Okay.
They have to be highly analytical to be able to really dissect complex systems and identify those weaknesses.
Right.
But I think even more importantly, they need to be creative.
Creative.
Yeah, they need to be able to think outside the box, find unconventional ways to bypass those security controls. It's almost like thinking like an attacker.
But with ethical boundaries.
Exactly. And given how quickly technology changes, you need to be adaptable.
Always learning.
Absolutely.
Yeah.
A constant thirst for knowledge is essential.
Yeah, it sounds like a pretty continuous learning curve.
It is.
And with all this ability to uncover these security flaws, I imagine ethics are a pretty big deal in this field, right?
They are huge. Ethical considerations are paramount in penetration testing. All testing must be conducted with a strong moral compass and, really importantly, explicit legal permission from the organization being tested.
So you can't just go around hacking into things.
Absolutely not.
You need permission.
You need permission, and this permission is formalized through what are called the rules of engagement.
Rules of engagement, okay.
So this document clearly defines the scope of the testing, what specific systems can be targeted, and any actions that are completely off limits.
So everyone knows the boundaries.
Exactly. And before any testing even begins, it's crucial to have detailed discussions with the organization, answer any pre-engagement questions they might have, just to make sure that everyone's on the same page about the boundaries and objectives.
So it's all about transparency and communication.
Absolutely.
Okay, so we've laid a really solid foundation here, talking about the core concepts of penetration testing. But I know you've also highlighted some specific techniques and tools from the guide that you can share with the learner
Oh, yeah.
to give them a more concrete understanding of how this all works in practice.
Definitely.
What do you have for us?
Well, let's take an example from active reconnaissance.
Okay.
We talked about Nmap earlier.
Nmap, right.
So a tester could use Nmap to perform a really basic scan on a target system.
Okay.
Let's say, just for example, the IP address is 192.168.1.10.
Okay.
And a simple Nmap command could reveal which ports are open and what services are running on those ports.
So what kind of things would you find?
Well, for instance, finding port 80 open, that would likely indicate that a web server is running on that machine.
Okay.
And these open ports are really significant because they represent potential avenues of attack. It's like, as we said before, finding an unlocked door. It doesn't necessarily mean you can just walk in, but it's definitely worth investigating further.
It's a starting point.
Exactly.
What about those password-based attacks we touched on earlier? How do those actually work?
So penetration testers, they might simulate password-based attacks using techniques like brute force attacks.
Brute force.
So this is where they systematically try a huge number of possible passwords until they find the correct one. And while this is pretty effective against weak passwords, it can be really time-consuming.
Because you're just trying every combination.
Right. And it can be pretty easily detected as well. A more targeted approach is a dictionary attack.
Dictionary attack.
So this uses precompiled lists of common passwords called word lists.
Word lists.
And there are collections like seek lists, which contain just an enormous number of these lists, categorized by different types of applications and potential password patterns.
Wow.
And there are even tools like Seal that can actually crawl a target website and generate a custom word list based on the words and phrases found on that website.
Oh, that's interesting. So they're using the website itself to try and guess passwords.
Exactly. So this increases the chances of actually guessing a legitimate password.
Makes sense. And you mentioned tools for automatically finding known weaknesses.
Yeah, so vulnerability scanners like Nessus and GVM play a huge role in identifying these known security flaws. They work by comparing the software versions and configurations of the target systems against a database of known vulnerabilities. And these databases are constantly being updated.
So they're always up to date with the latest threats.
Exactly. So if a match is found, the scanner will report the vulnerability and often provide information on its severity and how to fix it. It's kind of like having a security encyclopedia that automatically checks your systems for any known issues.
Okay, that's pretty handy.
Yeah.
You also pointed out that the WannaCry ransomware attack is a real-world example.
Yeah.
How does that tie into all of this?
So the WannaCry attack, which spread so rapidly you might remember,
I do, yeah.
it exploited a vulnerability called Eternal Blue,
Eternal Blue.
which was present in older Windows systems that hadn't been patched. And this really highlights how important vulnerability management is.
Keeping your systems up to date.
Exactly. Penetration testers often look for these unpatched systems because they represent really easy targets for attackers.
Low-hanging fruit.
Exactly. So by identifying these vulnerabilities during a test, organizations can take proactive steps to patch them before a real attacker can exploit them. And this could potentially prevent widespread disruption like what we saw with WannaCry.
Right. It's about being proactive instead of reactive.
Exactly. And it really underscores the real-world impact of these vulnerabilities.
Yeah, it shows that this stuff isn't just theoretical. It has real-world consequences.
Absolutely.
What about after gaining that initial access? You mentioned things like lateral movement and getting data out.
Right.
Are there specific techniques for those?
Yeah, definitely. So for lateral movement, which is basically moving from one compromised system to another within the network,
Okay.
testers might use stolen credentials or exploit vulnerabilities on those internal systems to gain access to more sensitive areas. And tools like CrackMapExec and Impacket, these are often used in Windows environments for this purpose.
So they're using the tools of the trade.
Yeah. Then there's persistence, which is maintaining that unauthorized access.
Persistence. Okay.
This can involve techniques like installing backdoors or creating new administrative accounts.
So they can get back in easily.
Exactly.
All right.
And for data exfiltration, which is the process of secretly copying that data out of the network, tools like Packet Whisper can simulate this, showing how an attacker might actually extract sensitive information once they have access.
Clever. You also touched on intercepting communications, man-in-the-middle attacks. How do those work in practice?
So man-in-the-middle, or main-TM attacks, they involve intercepting the communication between two systems without either party knowing.
Oh, so you're eavesdropping.
Essentially, yeah. And tools like Ettercap and Wireshark, these can be used to capture and analyze the network traffic that's passing between those two systems.
Okay.
And if the communication isn't properly encrypted, this captured traffic can reveal all sorts of sensitive information, like passwords, credit card details, anything that's being transmitted in plain text.
So it's like eavesdropping on a private conversation.
That's a good way to put it.
And you mentioned remotely controlling compromised systems, this command and control thing. That sounds kind of like something out of a spy movie.
Yeah, it does, doesn't it? So command and control, or C2, is all about once a system is compromised, attackers often want to establish a channel to remotely control that infected machine.
Okay.
So they can issue commands, receive the results, and basically do whatever they want with that system. And this allows them to perform further actions within the network.
They're basically taking over.
Pretty much. And penetration testers, they use C2 frameworks too, like Empire and Starkiller.
Okay.
And these frameworks allow them to manage and control multiple compromised systems during a test. So they're simulating how a real attacker might coordinate their activity across a whole network.
I see. So it's not just about compromising one system. It's about how an attacker might use that to gain control of the entire network.
Exactly, and this really helps demonstrate that potential for widespread impact if multiple systems are compromised.
Makes sense. Finally, you mentioned Active Directory attacks. That's a pretty fundamental system in a lot of organizations, right?
It is. Active Directory is basically a centralized directory service that's used in a lot of Windows-based networks to manage users, computers, security policies, that kind of thing.
Yeah.
And because it's so central to everything, it's a prime target for attackers. So tools like Bloodhound.py, this tool can help penetration testers visualize the relationships within an Active Directory environment.
Okay.
So they can identify potential attack paths that might allow them to escalate their privileges and potentially gain control over the entire domain.
So they're finding the weak points in the system.
Yeah. It's kind of like mapping out the keys to the kingdom within a network.
That's a good way to put it.
Yeah.
Wow. So we've covered a lot of ground here talking about the tools and techniques of penetration testing.
We have.
It can definitely feel like a lot to take in, especially if you're just starting to learn about this stuff.
Yeah, no doubt. And the world of cybersecurity is so vast, it's constantly changing.
Always evolving.
Right. And honestly, our aim here wasn't to turn you into a penetration testing expert overnight.
Right.
It was to give you that solid foundational understanding of the key concepts and how they actually play out in the real world.
Exactly. The main takeaways here are, first, the systematic approach of penetration testing, from gathering that initial information all the way to reporting those findings.
Right.
Second, the different types of tests that could be conducted. And third, those ethical considerations that are so important to everything in this field.
Absolutely. And seeing some of the actual tools and techniques that are used, that helps make these concepts a little bit less abstract.
Yeah, a bit more tangible.
Mm-hmm.
So, the learner, we really hope that this deep dive has given you a valuable shortcut to understanding this really crucial aspect of cybersecurity.
We really do.
Whether you were just curious, whether you're preparing for a discussion, or maybe you're even considering exploring this field further, you should now have a much clearer and more informed perspective.
And if any of the areas or tools that we talked about today piqued your interest, we encourage you to delve a little deeper.
Yeah, keep learning.
The guide you shared even referenced some really important frameworks and standards, like the cyber kill chain.
The ITR ATT&CK framework.
Right, and the penetration testing execution standard.
PTE, yes.
Yeah, all of these are excellent resources for further exploration.
Awesome.
So yeah, check those out.
And finally, we want to leave you with something to think about. Given this constant arms race, really, between cyber attackers and defenders,
Mm,
and how quickly both the attack techniques and those penetration testing methodologies are evolving,
right.
what do you believe is the most significant challenge that organizations face in proactively maintaining a strong and resilient security posture?
That's a good question.
It's a complex question. There's no easy answers. But it's something that's definitely worth pondering as you continue to learn about this fascinating field.
It is.
Thanks for joining us for this deep dive.
Thanks, the learner.